Okay, so let's complete 7.6 and 7.7. Finding general solutions using separation of variables, basically to separate and integrate. And then from those general solutions, finding the particular solution, which basically just means solving for C using some form of initial condition, which they will give you. So what is separating of variables? Up until now, we have only been able to solve two types of differential equations analytically. An equation that is just as y prime is equal to f of x, where there is no y on this side, and dy dx is equal to f of y of x, or y double prime is equal to f of x. Again, the idea is that f of x is with respect to x, and x and y are not like intermingling within the derivative function or the second derivative. In this section, we will now solve a more general type of differential equation. Differential equation just means a derived equation. The strategy we will use is rewriting the equation so that each variable occurs on only one side of the equation. This strategy is called separation of variables, which basically means that once you separate, you're able to integrate. So we want to solve the differential equation y prime is equal to 2x over y. Well, dy dx, or the change in y over the change in x, is equal to 2x over y. What we want to do is we want to get all y's with dy, and we want to get anything that has an x with dx. Constants, okay, or coefficients, it doesn't really matter which side they go to. They can stay with the x or they can move over to the y side. It doesn't really matter. So this one is pretty easy. All we got to do is multiply both sides by y. That way you cancel out the y on this side. So you have y dy dx equals 2x. And then to get this dx with that 2x, we're going to multiply both sides by dx. Now, at some point, you don't have to show all of this work. You'll be able to do some of these problems in your head. But now we got y dy is equal to 2x dx. And once we get it in this notation, which is basically like this one is saying f of y times the change in y, and we have f of x times the change in x, we've separated the variables, and now we are able to integrate the correct notation on both sides. And now the integral of y is going to be y squared over 2 equals 2x squared over 2. And the c is always going to go on the side that's with the x. That's just the rule of thumb. And once we get to this step right here, what we have to do is we got to solve for the function of y. So we got to get y by itself. Now, a common mistake is when you are solving for y is to include this c. Just remember that c is just a coefficient. We don't know what that coefficient is, but it's just a coefficient. So anything that you do to this function, so for example, when I multiply both sides by 2, right, to cancel out that 2 is going to multiply into x. It technically is multiplying into c, but c is just a constant in the integral equation, and 2 times c is still a constant. So we're not going to call it 2c. We're just going to keep it as 2c. So we're never really going to distribute or multiply numbers to c. C is not going to change, okay? So now we have y squared is equal, those 2's cancel out, 2x squared plus c. And then the last step is going to be taking the square root of both sides. So we got y is equal to plus or minus the square root of 2x squared plus c. Now, if this was, if we were able to separate this c, we could take it out, but we can't separate it because of the plus sign, right? And that is going to be our original function. And this is called the general solution because we did not solve for c. We don't have an initial condition to solve for c. So original differential equations, you could see something that looks like this, right? Where dy dx is within the problem. Now this one, you can subtract x squared on both sides. And then you can multiply by dx. And this way we have separated and we are ready to integrate. A problem like this where it's y prime, remember that y prime just means dy dx. And both of these are x. So we want to divide both sides by sine of x. And then using our trig definitions and trig identities, cosine over sine just becomes cotangent of x dx. Here's another one. So here we got x y prime over e to the y plus 1 equals 2. All right. So remember algebraically, okay, if I rewrite this as just dy dx times x times 1 over e to the y plus 1 equals 2, it makes a little bit better sense, right? I can multiply both sides by dx. And then I can also divide both sides by x. That dx will cancel out that dx. And dividing by x, both sides will cancel out that x. And then you're left with this part times dy, and on this side you have 2 over x dx. So some of them look a little bit trickier. You just got to make sure that you use correct algebra. So here's example 2. Let's solve the differential equation. When they say solve the differential equation, they basically mean find the general solution. Sometimes they'll say solve the general equation given the initial condition so-so. That just means find the general solution and then the particular solution. All right, so looking at this problem, here's my rewrite. I always like to rewrite my problems. Well, I know that I got to get cosine of y with dy, and then I got to get dx with the x cubed. Well, that's easy enough, right? Multiply both sides by cosine of y, and at the same time, I'm going to multiply both sides by dx. The dx cancels out on this side, the cosine of y cancels out on this side, and now we're left with cosine of y dy is equal to 4x cubed dx. We separated, now we are able to integrate it. The integral of cosine of y is going to be positive sine of y equals, the integral of 4x cubed is 4x to the 4th over 4, which is just x to the 4th. And then don't forget your plus c with the x, okay? It always goes with the dx. Well, how do we get y by itself? This is a trig function, and you know that if you take the arcsine of both sides, arcsine of this and arcsine of this, the arcsine cancels out the sine, and you're left with y equals arcsine of x to the 4th plus c. Now, again, if you're able to separate that C, do so algebraically. In this case, we cannot do that. We can't separate it because of the plus sign. All right, now how do we find that particular solution? So finding the particular solution. Well, the only difference between finding the general and the particular is that with the particular solution, you have to go one more step and solve for C. That's basically it. So first off, we are still going to find the general solution. And then we're going to use the initial condition, which is 2 and -3, and we're going to plug those into the general solution to help us solve for C. That's all it is. All right. So let's first, I'm going to start off by rewriting my function. And looking at this, excuse me, the x squared plus 4 and the dx all have to be on the same side, and the dy has to be on the same side with the dy. And remember, you cannot put dy in the denominator, so you're not going to be able to divide by dy. The dy and the dx have to stay as numerators so that you can actually integrate it. Well, step 1 is I can divide, or just for showing correct notation, I'm dividing by y on this side. So I'm going to divide by y on this side. By doing that, this y cancels out and it moves over. And then at the same time, I'm going to divide by x squared plus 4, right? So I'm just going to write it one more step, okay? So we've got x squared plus 4 dy dx times 1 over y equals x so far. And that is together. And now I'm going to divide both sides by x squared plus 4. That cancels out. And I'm able to move that dx by multiplying both sides by dx. So you can do all of these things in one step, okay? If you see it, just do it. It is important to write the step that shows that separation, okay? So you do have to rewrite 1 over y dy equals x over x squared plus 4 dx. That has to be written if it's a FRQ question. All right, now that we've separated, everything looks like it's where it should be. I'm going to integrate. And the integral of 1 over y is ln of the absolute value of y. And then how do we integrate this guy? Well, some side work. We got to use u sub, right? Let u equal x squared plus 4. So du is 2x dx. Divide both sides by 2. So let's take out that half. And we've got the integral over u du. So let's come back over here. Now we got ln of the absolute value of y is equal to 1/2 ln of the absolute value of u, and u in this case was x squared plus 4, absolute value, and then plus c, okay? So Now this right here, when you're finding the particular solution, you don't have to solve for y right off the bat. I'm going to leave this as is, and then I'm going to solve for c right here. So this is the part that I'm going to say don't solve for y yet if finding the particular. So I'm going to take my initial conditions, which is y is equal to 2, x is equal to -3, and I'm going to plug it in to that general solution to help me solve for c. So this is going to be ln of 2. I can eliminate those absolute values because 2 is a whole number, positive number, times 1/2. And then here we got ln, again, -3 squared plus 4 plus c. So ln of 2 is equal to 1/2. I can eliminate those absolute values because -3 squared is 9 plus 4 is going to be 13 plus c. So now what is c? C without a calculator is equal to ln of 2 minus 1/2 ln of 13. And it's okay to have a c that looks this ugly. Okay? If you wanted to clean it up, obviously what we can do is rewrite our half as an exponent for 13. So that's going to be ln of square root of 13. So c is going to be ln of 2 minus all of that. So that's going to be division. So it's going to be 2 over the square root of 13. So there's our c. Now that we have our c, we're going to come back. We're going to take that c, we're going to come back here, and we're going to solve this guy for y. And when you solve it for y, obviously, how do we get y by itself here? We're going to raise both sides with a base of e. So it's going to look like this. E ln of y is equal to e 1/2 ln of x squared plus 4 plus ln of 2 over square root of 13. Now here is a common mistake when we have e. Remember, when you have a plus sign with a base this can be split up. All right, so keep that in mind when you see me do this. So now we have the e and the ln will cancel out. So we've got y is equal to e to the ln of x squared plus 4 raised to the half, or square root. Okay, I just moved that up, right? Times, okay, times e to the ln of 2 over square root of 13. So this is the property of exponents. Because we have a plus, we can separate these into two different numbers. Now this right here is just a number. It is an ugly number, but it is just a number. So now I can bring this number, but please keep in mind one more thing. I almost forgot this. Because you have e to the ln and e to the ln, what does that do to this actual problem? You have a common base and it's raised to the ln. Well, just like before, this actually does cancel out on this side, and you're left with just the square root of x squared plus 4 times 2 over square root of 13. Or better yet, 2 over square root of 13, because that's just a coefficient, is times x squared plus 4. And there we go. There's our particular solution. Most of it, if you noticed, was algebra. All right, example 4, which I believe we have one more example after that. So let's see which one. All right, I'm going to leave example 4 for you. You guys try that. If you can't figure it out, obviously use the QR code. Let's do example 5 together. So find the equation of the curve that passes through the point 1, 3. So right here, they're telling you that the original curve passes through that point. So this is an initial condition. All right, this is a condition that's coming from the original function. And has a slope of y over x squared. So this right here is our dy dx. And it is a slope of dy of y over x squared at any point. Be sure to state the domain of your solution equation. So this is obviously a separation of variables problem. So we're going to start off with dy dx is equal to y over x squared. So we want to find the equation of the original curve. So we want to find the particular solution because they did give us an initial condition. All right, easy peasy, right? Multiply, if I multiply this side by dx, and then I'm going to divide this side by y. So we got 1 over y dy is equal to 1 over x squared dx. Now we can integrate because we have separated, and we got ln of y is equal to negative 1 over x plus c. So far we're on our way to the general solution. And again, because I want to find the particular solution, I'm going to now solve for c using 1, 3 before I rewrite my particular solution. So this is going to be ln of 3 is equal to negative 1 over 1 plus c. So c is equal to ln of 3 plus 1, right? Sometimes with the ln values, it's better to write 1 plus ln of 3, just so that you don't confuse that 1 belonging to inside the ln or not. All right, now that we've solved for c, we have almost our particular solution. So this is almost our particular solution, right? This is technically the particular solution. You will get the majority of your points for just getting to this point right here. But with multiple choice problems, and sometimes they will say make sure to simplify. So when you want to state the domain of your solution equation, you want to simplify that equation so that you can state the domain. All right, anytime we have ln, the only way to get y out is we have to raise both of these with a base of e. So that will cancel out right there, and we're left with y is equal to e to the negative 1 over x plus 1 plus ln of 3. So when you have a common base with things that are added together, I can break this down into y equals to the e negative 1 over x plus, times e to the 1 times e to the ln of 3. Well, you notice this part right here, e to the ln, that 3 just comes down. So now we got y equals, I'm going to put the 3 in the front, okay? And we got e to the negative 1 over x times e. Now this doesn't look that pretty, so this would be a good example of basically bringing back the e to the negative 1 over x and e to the 1 together as 3e to the negative 1 over x plus 1. Just bringing them back so that it looks a little bit nicer. And that's it. This is our particular solution. Now, sometimes you might notice in multiple choice, if you have an exponent that looks like this, they might get a common denominator and bring these guys together. Okay, so if you see that the answer, if they multiply the top and bottom here by x, and you end up with y equals 3e to the x minus 1 over x, that's the same thing. And that is the original function given that slope. All right, guys, that's it for 7.6 and 7.7. Enjoy.